Hello once again, it's Matthew from Matthew Northey Music here, and I'm outside today. I'm actually outside the shed, and I'm going to be going in there in a minute to do a little repair, but as it was a nice day I thought I'd start the video outside. Now, as always, if you like these sort of videos, please think about liking them and subscribing to the channel and clicking the little bell icon if you want to be kept up to date with any other new videos that are coming along. Anyway, what is today's video about? Well, today is an amplifier repair video, but it's about an amplifier that's very special to me, and we'll go in the shed and we'll have a look. Well, if you followed my channel over the last couple of years since I started, then you may well have seen one of these before. This is an amplifier made by GP Electronics. And just as a recap, GP stands for Gerry Pope, and he is an inventor and electronics engineer based in my hometown of Bovey Tracey in Devon. And during the late 60s and early 70s, up to about 1980, 81-ish, he used to build amplifiers, and he built a lot of custom-made amplifiers. What makes this amp even more special is above the GP logo, you'll see a sticker that says Bill Greenhouse, Sound of the Southwest. And that was a music shop based in Exeter, and that was one of the first jobs I ever had. Is I worked there as the engineer, and I also sold guitars in the guitar department, and I was there from 1992 to 1994. Anyhow, on another video on my channel, I actually did a clip of me playing through one of these amps, doing an All Living Fear tune, which I'll put a link to in the bottom. But this amp is slightly different, and it's different because it's got a built-in phaser. Now, as I mentioned earlier, GP used to make a lot of custom designs for people. And here you can see this phaser is basically an add-on. So you've got the control here, and then you've got the on-off switch there, and you've also got it on a toggle. Now, this would have been designed for somebody who wanted a standard amp, but they wanted a phaser built in, and so GP just fitted one. And the interesting thing is going to be what is the circuit inside it, whether it's a GP designed circuit or GP made circuit, or whether it's literally a phaser pedal that's just literally been stuck inside the cabinet, which possibly may have happened, especially if the customer who already owned this phaser pedal. Anyhow, I've been after more GP amps ever since I can remember, and this one happened to turn up on an auction from a music company based in mid-Devon, and they actually contacted me, probably because of the videos I put up before, and said they had this amp for sale. So I put in a bid, I won the amp, and I drove up to mid-Devon and picked it up. So here it is. Looking at the back, it's got the standard GP Electronics plate with the model number and serial number. And on the other side, it's got a bolt-in mains connector with what looks like its original screws. Now, I would suspect this amplifier has not been used for an awfully long time, because generally anybody that has used one of these in the last 30 years would have swapped out the bolt-in mains connector for a standard IEC, which is one of the things I will be doing to this amplifier. Well, these amps are kind of modular. You've got the preamp, which is all fitted to the front panel, and then the power amp is a separate unit that's inside the amp. So what I'm going to do first is I'm going to take off the front panel, and then going to take the amp out, and then we'll have it all out on the desk to have a look at. I'm just propping this up with a roll of cable just so we can pull the front off. As you can tell, there's no knobs on this amplifier. However, I have got a solution for that, and which I will talk about later in the video. But yeah, here we go. This is the inside of our amp. And as I said, is this somebody else's phaser pedal? And yeah, it's made by a company called Maxon. So it's a Maxon phaser, and it's in a little plastic case. I would guess that's probably out of a pedal, and it has literally just been added. They've extended the wires that were in the pedal to this control, and they've made a foot switch here. So yeah, that's definitely just an add-on, and it was kind of glued onto the back there. So in a way, it's a shame it was added, because, you know, if it's a nice sounding pedal, it would be probably quite nice to put that back in as a pedal. But this is how the amp was made, so it's going to stay like that. If we look here, we've got our mains on off switch. So mains comes in here, goes through the switch, and then they've got the fuse wired coming out of the transformer, going into the back into the circuit. I don't like this kind of wiring. I actually prefer it not to be on the front panel at all. I don't like mains getting too close to other things, especially like this. Not sure what I might do. I may end up getting a fused IEC mains connector and putting that in the back, and then we don't need to have the fuse on the front. I'll keep the fuse there on the panel, but it won't be connected. I might even get a fused IEC mains connector with a switch on it, and then that will then remove all of the mains from the front panel. I know it takes it to being non-standard, but I just don't really like mains on the front panel. But I mean, it's going to be safe enough. I will properly earth the front panel because I'm not sure that it is actually properly earthed. That's one of the things I'll do. I mean, that was how they did things back in the 70s. So anyway, there's this wire here that goes to the IEC mains, which is actually sort of tucked down in that corner. We've then got this multi-connector here, which again was standard on all of Gerry's amps. And that goes to the power amp. And you know, this is kind of how they did it. They made these like modular power amps that were 130 watts. Some have said that they're similar to amps in Hammond organs. And you can say there's a wire here flying to the phaser, so the phaser's getting its DC from a tap off the power supply somewhere. So what I think I will do is I'll just grab a screwdriver and I'm going to disconnect this rather Heath Robinson looking like power wire. I mean, it will be reconnected at some point. I'm then going to see if I can thread this, take the mains out. And there's our mains that's going to that bulging connector. I mean, whatever happens, that bulging connector isn't staying, so I'll just snip these wires. Interesting though that they are the more modern type of mains wire. You know, it's the standard, you know, the standard color coding that we have today. That makes me think this may be one of the latter built amps. I mean, there's a testing label on there. I'm going to look closer and see if it's got, see if we can read the date on it. But yeah, so that's our preamp. I mean, it's very simple. I mean, the preamp circuits were 2741 op amps and then some tone on it. And the same goes for the second preamp stage, but this stage has got the sustainer circuit built in, so there's a few extra components, although it's hard to tell what they are. I mean, there's obviously that capacitor there. I think basically what it does is the sustainer circuit just basically stuck a lot more gain in. And there's that capacitor there that isn't on here, but and that capacitor there. So, but you know, they're very, very similar circuits. Very similar circuits. But yeah, that's the main difference between the two inputs. And then we've got this link button here, which kind of joins the two channels together, so you can have your fuzzy sustaining circuit as well as the clean channel, if you like, which is here. And then we've got this phaser control. As I said, we've got a little toggle switch which isn't working too well, so that will probably come out, and I'll probably replace that. And then we got our phaser, and the actual phaser knob's not turning at all, so I don't know if that's got jammed or something. If I get some contact cleaner, which you just happen to have here, squirt some of that in. Can I turn it now? No, let's get a pair of pliers. I mean, you know, it looks pretty rusty. I think I'll probably end up replacing it anyway, but yeah, that's not turning at all, is it? Oh, it is now. Or is that the whole socket turning? That's the whole socket turning. Yeah, so that pot's going to have to be replaced, but that's no problem. I've got tons of pots. But yeah, all the jack sockets are fine. So yeah, that panel looks okay. So the next thing I'm going to do is take out the power amplifier. It is quite crude really that the power amplifier is literally held in with 3 wood screws that kind of go into the metal. But you know, it's functional, but you probably wouldn't see that on a, you know, a modern Marshall. You know, they would have welded in nuts and bolts, but you know, 3 wood screws holds the unit in, and then we can take it out. And this is our power amplifier. Now, I think Gerry's power amps were really, really well designed. You've got a nice chunky transformer here with the power supply, and then we've got the main driver board here, and then we've got the 2 push-pull output transistors here, and they've got, you know, really nice solid chunky heat sinks on them, so you know they dissipate a lot of heat, and it's a really nice design. And as I said, Gerry used to make these power amps as standard, and then he'd put them in anything. One system I saw some photos of a little while ago was a nightclub disco system, and it had 4 of these amps in, and they went to 4 separate speakers around the club. And I think it also had like a panning control, so they could actually do a kind of Pink Floyd azimuth correlator, and they could actually pan around the venue, which is a really cool thing. But anyway, on the power amp board, if I just turn this around, you can probably see it a little bit better, but there's a couple of electrolytic capacitors here, and no other electrolytics on there, just these 2. And then on the power supply itself, which if I turn this around, you can probably just see it there. You can see there's a big electrolytic here, and there's actually a couple more here, 2 more there and 2 there. So what I will do with this, before I even think about powering it up, is I'm going to replace all the electrolytics on this board, and for good measure I think I'll replace these 2 electrolytics as well. Other than that, I think it will probably work. I mean, there's nothing looks blown, there's nothing burnt out or damaged, it just literally hasn't been used. So I am quite confident that this unit will work. But as I say, I want to change these capacitors first. Now, I'm not sure how well you can see this, but this is one of the 1000 microfarad 16 volt capacitors, and it's definitely bulging and leaking here. But just by comparison, this is how the capacitor would have been in you know, the late 70s, made by ITT. There was actually an ITT factory in Bovey Tracey, so these capacitors may have actually been manufactured, I'm not sure. But here I've got like a modern equivalent, and you can see it's a lot smaller, but it's still 16 volt 1000 microfarad. So I'm going to replace these with this. I've got the power amp board out of the chassis. The heat sinks were bolted in with wood screws again, but this is our PCB, and if I turn the PCB around, we also have on this board these coupling capacitors here, and these are 47 nanofarads. Now they've actually started to split down the edges, and as it happens I do have some polyester capacitors, and I think I'm just going to replace those. Even though they probably will work, they might start crackling and fizzing or whatever, so I kind of figured if I replace those 4 while I've got the board out, then at least then that's another thing we don't need to worry about. And this is what I mean about the edges of the capacitors breaking. There's a little crack on that one, but on this one you can see the edges actually fallen off. There we go then, a fully recapped power amplifier board. Now I'm not saying there might not be something faulty with this, because obviously I haven't tested it, but I have at least replaced all these capacitors and these 2, although I have now just spotted that tantalum there, and in fact there's a capacitor there as well, and I'm not sure of the values of these 2. So what I'm going to do is, I mean they physically look okay, but I will contact John or Gerry and see if they've got the circuit for this, just so I know what those values are, because I might well end up changing them out. Having said that, on the 3 other GP power amps I have, there's not been a problem with those, so they're probably going to be alright. I'm guessing that's just like a little bit of audio filtering because it's at the end of the board, but I really don't know. Whereas these are definitely linking different stages of the amplifier together, because I think this is the phase inverter circuit here, and I think this might just be a bit of preamp buffering, I'm not too sure. Anyway, that's that for now, and I'm now going to have to move on to the preamp, because I don't have the 2 other capacitors for the power supply. I'm going to have to order those. Now, another thing we got here is we've got this, the output, the positive output of the power supply, and then that's going through 2 resistors to come to this flying lead to drive that phaser controller. Now, I think rather than having 2 resistors, I think it might be much better to put a regulator in there. So I'm toying with the idea of putting a 9-volt regulator in, and then that way we get proper voltage to feed the phaser, because I can't for any life of me think the phaser is going to run on anything other than 9 volts, because it would have been designed that way. However, what I will do is, once we've got this all powered up, I will measure the voltage, because if it does turn out it needs a bit more, then obviously we'll give it a bit more. Quick look on the internet then tells me this is a Maxon phase tone phaser pedal, which has obviously been wired into the amp. So yeah, that will definitely run on 9 volts. So I am going to stick a 9-volt regulator into the power supply, just because I kind of think, well, if I put a regulator in it, at least it'll be the proper voltage. Anyway, so that's there, and then it's got its control here, which I'm going to change because obviously that's all welded in. But other than that, I'm not going to do anything else to that part of the phaser. And in fact, I kind of think at the moment I'm not going to start recapping this until I've heard it, only because if we look here, there's a lot of wires and things going from the board to the jacks and the switches, and I kind of think it's a little bit of a faff. So I just want to work out, you know, if it's sounding noisy when I test it, then obviously I'm going to recap it. But at the moment, all I want to do is I want to replace this pot so that the phaser's then going to work. I think I also need to change this switch, because the switch is it's not going clicky. I think it's kind of had it really. So I'm going to replace that switch with a, you know, some sort of I think it's a double pole single throw, a double pole, 3-pin in and out switch. I mean, it might be that I might even swap it out for a double pole double throw, so it becomes a true bypass. I think that actually might be a better way of doing it. Interestingly, that they've got the foot switch wired in, and I'm guessing that's kind of wired in how the original was, but it's got 3 poles on it, so I don't know if that means that it's going to stick some power down for an LED as well. I really don't know. I mean, part of me is thinking, well, if this is a max tone pedal, maybe I could remake that circuit and put that in, and then take this out and actually, remake it as a pedal. I don't know. Really don't know. No, I think I'll keep it as original. Interesting to note that they've added a diode there, protection diode over the circuit. So again, if this had been a pedal, they probably wouldn't have bothered, because it would have only ever run off a 9-volt battery. But they thought forward. Anyway, so we've got 2 wires here going to the pot. So I'm going to take the pot out, wire those in, because I'm guessing that's just for the rate, and then that bit's done. Okay, well, I've taken this pot out because I wanted to know what value it was, and at full angle it's saying it's 466k, so it's a 500k pot. Now if I turn this using this, you can see it's going down, and it's down to nothing. So if I sort of turn this halfway, and it's at 135, so it's a logarithmical potentiometer. But the weird thing is, even though it's really stiff to turn, it does appear to be working. I've actually got the pot open, and sadly there's no way of reviving this. It's just too jammed, and it's actually quite, it's black and mucky and horrible on the inside. So I think this is definitely a goner, so we're going to replace that anyway. Now the other thing I've done is I've also replaced the switch, because the old switch was completely broken, and fortunately there was enough clearance between the actual switch and the printed circuit board that it would fit in there and not get in the way. So Obviously looks different to these, but it's functional, it works, and our phaser control now works as well. Okay, well, I kind of want to give this a little bit of a test, and I have replaced one of the smoothing capacitors. There's only really a smoothing capacitor that he's doing, and looking at the original one, it looks in pretty good shape. I mean, there's no bulging, there's no, you know, it looks like it's probably all right. So what I'm going to do is, I've got my portable appliance tester here, and I'm going to do a class 1 test, because, you know, if there is a problem, then, you know, but anyway, it's passed. So I think what I'm going to do is I'm going to connect it up to a speaker and just see if we get any sound out of this. Okay, I did a quick test and I'm getting a horrible hum. That's like my Heath Robinson way of making up the other capacitor values, by the way, because I thought I'd better replace them. And I'm getting minus 36 on the minus rail, plus 42 on the plus rail, and 9 volts coming out of here. So that's not right. They should be about the same. So either something's crowbarring the power supply, or I don't know, we might have a diode out or something. But I think what I'm going to do next is disconnect the power amplifier circuit and then just measure the voltages again. Basically, I just want to measure the power supply under no load. So that's what I'll do next. Well, ages of time have passed since I last did anything with this. And I've actually got an amp here that is from a working GP IC 120. And the reason is, IC 130. And the reason is I want to just compare things between this amp and this amp. Now, there are some differences. There's basically different transistors, but I think it was down to whatever they had in stock at the time as to what they put on the board. For example, here there's a tantalum capacitor, and on the other one there's an electrolytic. Now on this board I have swapped out these two diodes here. They're 1N 4002, so they're 100 volt rectifier diodes. But the ones that I took out, I put them and I've tested them and they seem to work as they should do. So I think the diodes are probably okay. Now here I've replaced this output transistor. Now I put in the wrong transistor because I put in the complement to the 2N3055. I can't remember what the number was now, but it was the right. Here, it's here. Actually, that was a 2955. So yeah, I put in a 2955, and the thing just blew. Well, it just went. It burned out a resistor anyway. As it turns out, I put the wrong transistor in, so I've got the right one in there now. And again, I compared it with what was in here, and in here is 40636, but that is basically an equivalent of this, so it's kind of the same thing. So I'm hoping now this is all okay, but what I want to check before I power it on are these transistors here. These are the drivers for the output, and John said to me that if the outputs are okay and it's still playing up, it could be the drivers, so it's worth taking them out and swapping them out. So I'm going to swap these out as well, then I'm going to give it a test. Now also there's some bits on the power supply that are quite interesting, and it's these Zener diodes here. And basically what Gerry did with these Zener diodes, there's one here and there's one here that's actually broken, and I'm not sure if that works or not, but what they're doing is they're taking power off the main rails, and they're 15 volt Zeners, so you get 15 volts on the other side at about half an amp. And so effectively they're working like voltage regulators, and they will power the preamp section of this amplifier. But as it is, I'm not too bothered about that at the moment because it's just the power amp I want to sort out. And what I may actually do is desolder these, just because A, I'm going to buy some new ones, and B, I want to not power up the preamp if it's not getting the correct voltages. And next thing I'm going to do is check these two transistors. These are the driver transistors that drive the output transistors, and if one of these is dead, then that could be why there's a problem with the rest of the board. I've got the transistor in my tester, and I've done it a couple of times and I've moved it a couple of times, but this is what keeps happening. No unknown or damaged part. So I would say this transistor is probably dead. Now, fortunately, I do have a replacement, but I'm going to check the other one as well. Now this is the replacement I've got, and it's actually a used one, but it does work. And this I actually got from GP Electronics. John gave me a couple of bits for this amp, and this is one of them, this transistor. So I'm going to pop this in the board, and then I'm going to check the other one. This then is the other driver transistor, and I haven't checked it at all, so this will be our first test. I'm saying it's a resistor. No, we're saying that one's dead as well. So that's the 40595. And I also have another one of those, which I will just grab out of my little bag of bits. Right, there's our 40595. So I'm going to pop that in to the tester. There we go, let's look at that now. Yep, that's like it's a PNP transistor. The other one was NPN, which is correct. So I shall pop that inside. Well, I think I've made some real progress with this now. The two driver transistors here I've replaced, they were both dead. Now there's two transistors here. The one that was here, which is a BC214L, that was dead. This one, its complement was okay. This one was okay, and these two were okay. So I've ordered one of those to go in there. Hopefully that will come in the next couple of days. And once I've replaced that transistor, then I do think I can give this a test, because everything else now should be okay. Like I say, I've replaced these electrolytics here. I've replaced these capacitors here. I probably didn't need to replace them, but because they were a little bit they looked like they were starting to split, I kind of thought, well, I may as well replace them. But fingers crossed, once I've got that transistor in, we should have hopefully something a little bit more positive. I've done a few more things this morning. I've actually disconnected the power supply, so I've removed the good Zener diode here and the bad one there, so there's no power going to the preamp board at all. And these are the wires that feed the power amp. We've got our negative there, we've got our plus volts here, and we've got our minus volts here. And I wanted to purely check the power supply in out isolation to make sure it's working. So if I switch it on, we've got 44 volts coming out the power supply without load, which is good. If I then go to the minus rail and we do the same, we've got 43.98, so we have correct voltage on the power supply. So if we get any spurious results now, we know it's something loading the power supply, but the power supply itself is correct. Now I think, fingers crossed, we've fixed all the things we needed to fix. The board is actually looking a lot cleaner because I cleaned all the flux off using a toothbrush and some isopropanol alcohol, and it is cleaned up nicely. I've also removed and resat a few of the components, and that is because I wanted to test all the diodes. So all the diodes have been tested, and there was also a tantalum capacitor here. The other power supply's got an electrolytic, and I've just replaced it with a new electrolytic. The tantalum did kind of measure approximately okay, but I kind of thought for the sake of one transistor, I may as well just replace it. So that's all good. So the only other thing I'm going to do quickly is I'm going to briefly check all the resistors, but I think, to be honest, they're all okay. There's no sign of burning or anything on any of them. And all I've got to do now is wait for that transistor to turn up, and then I can put all this back together and we can give it a proper test. A few days have passed then, and we've got some parts. So we've got some transistors here, and in this envelope here, I do believe we should have our 15 volt Zener diodes, which, if I can get the packet open, that is. Yep, there's our Zener diodes, different colour, but they are what they are. So what I'm going to do first is I'm going to put in the transistor in here, and as with everything, I will double check on the photograph I've taken just to check which way it goes. So obviously that's facing opposite to the transistor here, so we'll get this one popped in first. Well, with that component now installed, I have slight nervous excitement because it's now time to test the power amplifier. Just to recap, I've changed that transistors. So that's 4 transistors. These 2 here are okay. That one was okay. I've swapped out 2 diodes here, which were okay actually. And I've tested all the other diodes, they're all okay. And I've tested these 2 transistors, they're okay. And I've changed these capacitors here, and I've changed these capacitors here. And I've measured all the resistors, and all the resistors appear correct. Oh, and I've replaced that resistor as well, which burnt out. Now, I will never know if it was because I put the wrong transistor in that I took out some of the other parts, or if they were dead anyway. But with the these Zener diodes disconnected still, so we've got no power going to the preamp stage, I'm going to connect this up, hook it up to my test speaker, and we'll see what happens. Okay, so we're hooked up to our test speaker. The preamp's not connected. Let's see what happens. Okay, it sounds like it switched on. There was a bit of a thud. And so that's good, I think. Right, well the Zeners are now mounted, and I've got them mounted up high off the board actually, because if these did get hot, the higher they are, then there's more space for the heat to dissipate. So next thing to do now is to switch this on with the preamp connected. And let's just see what happens. Yeah, okay. So we know our power amp is working. I've stuck some signal in, and it's coming out, so that's really good. I've got some tone going into channel 2 at the moment, but I've got everything turned down, so let's switch the amp on. Turn up that channel, turn up the master. There we go. So yeah, not the best sound, but we have got some sound. Yeah, that's actually quite loud. Let's go into channel 1. And there we go. Obviously I need to clean the pots, and I'm not 100% sure on the phaser yet, but we kind of have a working amp. Now that we've got the amplifier working, the next thing I need to do is to fit this IEC connector into the back of the amplifier case. So we're going to pop that in next. Well, our amp's all back together now in its case, but as you can see there's one thing missing, and that is it doesn't have any knobs. Now, I wonder where I might be able to find some. Well, if there's somewhere that will have some knobs for this amp, it's going to be here. GP Electronics. Now, this panel here is typical of the sort of gear that they used to make. This is a custom-built control panel for an in-house PA system that was in a pub in Bovey Tracey, and you can see it's got 3 mic inputs, it's got a background audio, which would probably have been a reel-to-reel tape machine, and a turntable input, and there's a master control here, and the main power controls on the end. And if you look at the back, you can see it's all made of Vera board, so this is a really early piece from the factory. And there we go, I've got a little bag here of knobs to go on the amp. Here we go then, I've got my bag of knobs that John kindly gave me, and I'm going to pop them on the amplifier. Now our amp has got all its knobs on, but you might notice it doesn't have any dots to identify what the level is on the amp. But if you look at my other IC130, then you can see it does have dots, and that's because they're actually painted on with a little paintbrush and some black paint, and therefore I need to get my paintbrush out and draw some little dots on there, and then it'll all be complete. But for now I'm going to take this to where I keep all my cabs, and we're going to fire it up and we're going to have a listen to it. Now, it may not be obvious to see from this image, but if you look at the amp on top, you can see that they're slightly different in colour. The top one is like a darker orange colour, whereas the bottom one is a more yellowy colour, which suggests to me that the new amp that I've got, or the new to me amp I've got, is actually a slightly later version, because it has that lighter colour, which is kind of how I remember them more when I was younger. Whereas the other amps I have are this sort of slightly darker orange, but I will appreciate that it might not come across so well on camera. Well, this is the day I've really been looking forward to. At last I can finally get to test this GP IC130 Mark II with a speaker and actually listen to what it sounds like. Now, for this demonstration, I'm just going to be playing my Reverend Reeves Cabral signature. I'm going straight in the amp, and I'm not going to use any effects at all. I'm just going to be straight amp and speaker. And I'll move the camera onto the amp so you can see what I'm doing as I'm doing it. And for this demonstration, it's literally just an SM57 in front of one of the speakers. These are all Celestians inside this Sound City cab, and it's an A-tone cab which fits with the amp. First off then, we're just going to use the clean channel. Now, the clean channel is on channel 1, that is. So we've just got volume, bass and treble. Now, we've also got a second channel here, and I'll talk more about that in a minute. But we're just going to stick with this channel first. So I've just got a little bit of level, and we've roughly got the tone. The tone's quite high and the bass is quite high. I've given it a good lift on both. And so it's a fairly respectable clean tone, but you can bring the gain up a bit. I'll just turn the master down a bit. And it's got quite a nice little bit of drive to it, and if you're doing like a blues gig or a country rock gig or something, I think that's to me it's a pretty nice sounding tone. And if we just whack the treble up just a little bit more. We give it a little bit more drive. So yeah, and that's pretty much all the way to the top. So I'm going to bring it back in, bring it down again, just turn the master up a little bit, and then we're going to look at the sustainer circuit. Now the sustainer circuit is basically like a big muff type sort of fuzzy sound, and so with the sustainer on you get this kind of sound. Yeah, it's a pretty nice gnarly fuzz sound that it's got. Now, you've got another thing, got a treble lift. So on the clean sound again, we add the lift to it. You know, this I'm doing everything with the bridge pickup on the guitar, but it almost gives it a bit of a Telecaster-y sound. then when you put the two together, then you get a real sort of 60s. You know, real sort of. So yeah, it's a real sort of gnarly, heavy, sort of psychedelic fuzz sound, which, you know, would have been the sort of sound people wanted in the sort of early to mid 70s with an amp like this. And I feel this kind of sounds a little bit more toppy than the other amp, but it might just be because of the age of the capacitors inside it. Anyway, we've now got this phaser. Now, I was a little bit confused because I assumed the phaser worked with channel 2, but I think it's more so the fact that was the only place they could fit it. So the phaser is actually connected in with the first channel. So I've turned the gain down a bit. Now, there's a reason for this. And it's because I think the preamp circuit here then goes into the phaser, and then it comes out of the phaser back into the loop. Now, the problem with that is the levels don't quite match. And we do get a little bit of distortion, but I'm going to try and get it as clean as I can. So there's it off. Then when I turn it on, you can hear the levels dropped a little bit. But, you know. So yeah, it's not sounding brilliant. When there's a bit more level, so it is driving, it sort of sounds a bit better. But I kind of think if I rewired this so the phaser came in before the preamp, then we wouldn't get this slight distortion, and there might even be like an impedance mismatch thing going on as well that's muddying the sound a bit. I'm not too sure, because of course this was originally an actual pedal that then got fitted inside the amp, so it would be more used to a much lower level signal going into it. But you know, it works. It works. It's not brilliant, but it, you know, it. You know, it's what it is. So, you know, that's not the best thing in the amp, but the, you know, the rest of it's great. So we're going to go into channel 2 now. This is just a basic clean channel. And it doesn't have as much gain as the first channel. And I think this was designed for higher gain instruments, so you could, for example, plug like a keyboard or an organ or something into it, because these amps were designed for more general purpose use. They were never dedicated guitar amps or bass amps or whatever. They were designed for you to plug in whatever ever instruments you want to into them. I'm a little bit out of tune there, but you know, that's a really good, decent, clean sound. Now, as for the volume, yeah, these amps are loud. These amps are massively loud. I mean, they're like, I mean, it says they're called an IC130. I think it's 130 watts. And I know the combo that they made, they called it an 80 plus 30. So yeah, and I think basically what Gerry managed to do was kind of tweak the circuit just to be louder than 100 watts, because most amps were 100. But I mean, really, this will blow your ears off, you know, without too much hassle or effort. And you certainly wouldn't want to crank it too loudly, even at a gig, because, like I said, these were designed for bands where you had no mic'd up PA and you just had to be as loud as possible. And they very much succeeded. And I think an amp like this, that's, you know, I'm gonna go with this being possibly, even the little light here, they're actually, I've just noticed they're actually all different on the other amps that I've got. And I would say this is one of the later ones. I would say this could possibly have been from the late 70s. It might even be maybe 1980, 81, round about the time they stopped making amps. It certainly is one of the later ones anyway. And yeah, and it now works perfectly. You know, it's got a great clean tone. I would have no issue in using this live. I'm getting a really good clean sound out of this in the cab, so I know if I plug my pedal board in, it will do the job. And I think, to most people watching, they wouldn't even know it was a solid state amp. They think I was just playing through a Marshall or something like I normally do. Well, there we have it. This has been one of my more successful videos, in that this beautiful old amp is now working as it should do, and it can now join the rest of my little collection of GP amplifiers. And it's a testament, I think, to Gerry and John that they designed these things, you know, round about the time I was born. And, you know, I've got 4 examples here, and they're all working as indeed they should be. And the fact these amps here, apart from the routine maintenance of replacing the capacitors in the power supply, the only repairs I've had to do to any of these from memory is this one. I had to change one of the op amps on, I think it was channel 3, it wasn't working, it was just churning out a shashy noise. So I replaced the op amp and it came good. So, you know, these amps, none of these have had any proper servicing in, I don't know, since they were made. And they're just working. It's working perfectly well. And this one now this has had, you know, most of its work done. Apart from maybe fiddling with that phaser circuit at some point, or possibly I may build a phaser circuit and replace that one and take that one out and put it in a box and have it as a pedal like it was when it was original. I don't know. I haven't quite decided what I'll do about that. But yeah, anyway, thanks for watching this video, and all being well, I'll see you on the next one.